Hello, this video is measures of position part 3. And we're going to start with the example 2 slide in the box plot section comparing two groups. Test scores for a statistics class held during the day are, and then they list the scores. Test scores for a statistics class held during the evening are, and those scores are listed. Create a side-by-side box plot to compare these two classes. So for this one, we want to pull up our calculator, and what I've done so far is in L1 I put the scores for the day class, and in L2 I put the scores for the evening class. Now I wanted to show you that you can create a box plot in your calculator. So we want to go to stat plot. Once you put the data in first, then go to stat plot, which is a secondary function above y equals. So you'll hit second y equals to get there. And you'll see plot 1, plot 2, plot 3, plots off. We want plot 1. You want to make sure the other ones are off. So hit enter for plot 1. Make sure you turn it on. Hit enter for on. Under type. Now I need to show you this. There are two types of box plots. Okay, the first one is here. It's blinking. That's a modified box plot, which I'll show you how to do that later in this video. And here's a regular box plot. We want a regular box plot in this case. And my X list, decide which X list you want. L1 is where I have the day scores. So I want to keep that, keep frequency 1, and hit enter. Then we're going to do a second box plot. So second y equals again, and this time I'm going to turn on plot 2. So plot 2, I'm going to hit on. I'm going to change the type to a regular box plot. Now my X list I need to change because for the evening scores, I put those in L2, so I'm going to hit second 2 for L2, frequency is 1, and we're good. So to graph, instead of hitting graph, to make sure we have the appropriate window, hit zoom 9. Let's try this again, zoom 9 for statistic. And there we go, we have both box plots. You can hit trace, and you can see this is L1, where the cursor is. It shows the median. If you look at the bottom of the screen, you'll see the median is 74.4. If you arrow to the right, it goes to Q3, which is 82.5. The maximum is 99. If you go to the left, Q1 is 56, and the minimum is 32. If you want to see the second box plot and trace it, use your down arrow. You see the minimum is 25, Q1 is 77, Q2 is 82, Q3 is 89.5. The max is 98. Now what can we do with this? Well, we can compare and see which class you think did better. Now, the highest score here is 98. The highest score of the other class is 99. So you might think the first class from the day did better. However, you don't want to look at just the highest points. You want to look at the spread. This one looks more consistently spread throughout from the lowest to the highest. If you look at this, it looks like each one of these pieces of the box represents 25%. So there's 25% here, 25 here, and this line is 25. So 75% of the scores of the evening people are from 77 and up. So 75% of the students scored a high C or better, whereas this one, 75% of the students scored higher than an F. So I think this one definitely did better. I think the majority of the students did really well, and then you had this, someone made a 25, so maybe that person, maybe they didn't come to class like they were supposed to, maybe they didn't study, that kind of thing. So it definitely looks like the evening class did better. Okay. Now you can draw that out too. Just make sure you draw both above one another like we saw in the calculator, above one number line. So thinking of that 25, that student that made a 25%, that was a really extreme value. It was not like the rest of the data. Most of the students scored a high C or better. This student scored a low 25. So it seems really out of place. So numbers like that are called outliers. Outliers are extreme values that are much higher or much lower than the rest of the data set. Values that are outliers are not typical of the rest of the data. So that 25 wasn't typical for the class. Now sometimes we have outliers because there's an error in the data or an error when you input the data. Sometimes you'll type, let's say you were typing 95 and you accidentally typed 35 instead, that kind of thing. But other times they are out of the ordinary observations, like that 25. So before we can learn to find whether a data value is an outlier or not, first we must learn to find what is called the interquartile range. This is an important formula you want to write down. Interquartile range is just the difference between the upper and the lower quartiles, Q3 and Q1, so just subtract them. And we use IQR for short, so you don't have to write out interquartile range. So IQR is Q3 minus Q1, and you will need that in the outlier formula. Now, to find the outliers, what we consider an outlier, what we find is a formula that finds the boundaries for the outliers. So you find a lower boundary and an upper boundary, and any number that is less than the lower boundary would be considered an extreme value or outlier, and anything that's higher than the upper boundary would be considered an extreme value or an outlier. So here are those formulas. For the lower boundary, we start with Q1 and we subtract 1.5 times the IQR. So again, you have to find IQR first. For the upper outlier boundary, it's Q3 plus 1.5 times IQR. You definitely want to write those formulas down because you're going to need them. Alright, so here's an example. Find outlier boundaries for the following set of data. Then decide if there are outliers. If there are outliers, list them. So I'm going to pause for a second so that you can put this data in your calculator because you want to find your quartiles to be able to find the interquartile range. So as I'm looking at these, I'm thinking 3 might be an outlier. Maybe 85 is an outlier, but we really need to see and see what those outlier standards are according to the formula. So when I put this list into L1 and I found var stats, I found that the Q1 was 26 and Q3 is 32.5. So now we're going to use that to find our IQR. So 32.5 minus 26 is 6.5. So that's what we're going to use to find the outlier boundaries. So if you remember, the lower boundary is Q1 minus 1.5 IQR. So Q1 is 26 minus 1.5 times IQR, which is 6.5. So that's 26 minus 1.5 times 6.5, which is 9.75. And 26 minus 9.75 is 16.25. So basically, this is the lower boundary. This is not an outlier that we just found. This is the boundary for outliers. So anything that's lower than 16.25 would be considered an outlier. So in this case, 3 is definitely less than that. So let's do the upper boundary. So for the upper boundary, it's similar, but it starts with Q3 instead, and instead of subtracting, we add 1.5 times the IQR. So we have 32.5 plus 1.5 times 6.5. Looks like an 8, but it's a 5. 32.5 plus 9.75. So 32.5 plus 9.75, we get 42.25. Again, this is not the outlier, it is the upper boundary. So anything higher than this number in the data set would be considered an outlier. So what number, if any, is less than is greater than, 42.5? Looks like 85 is. So our outliers there are two, are 3 and 85. Now, just because a question asks you if there's an outlier doesn't mean there's going to be one. Sometimes there's none, sometimes there's 1, sometimes there's 2, sometimes there's 3. You just need to find the boundaries and see if there are any numbers that fall outside of those boundaries, to the left of the lower, to the right of the upper, and those would be your outliers. Okay. So that brings us to modified box plots. This is the kind of box plot that we're normally going to do. It's a box plot with outliers graphed as well. Okay, so to do this, basically, you are going to graph it the normal way. This is still Q1. This is still the median. This is still Q3. Okay, now here's the difference. This might be the minimum. This might be the maximum. However, it can't be an outlier. The endpoints, the normal endpoints, the normal ends of the whiskers, the horizontal lines cannot be outliers. So basically what we do is we star, you can use asterisk, you can use a star, you can use an X, you can use a big dot. You, in some way, make a special mark above the outliers that is separate from the box plot. And then what happens is, so like in this case, this number can't be the max because the max was an outlier and it's right here. So this number here is the highest number in the data set that is not an outlier. This number here is the lowest number in the data set that is not an outlier. Okay, make sure you star the outliers. Okay. Okay, so we're going to create a modified box plot here. So if we need to first find the outlier boundaries to see if there are any, so we need to find the IQR first, which is 89.5 minus 77, and we get for our IQR 12.5. So for the lower boundary, that's Q1 minus 1.5 times 12.5. And if you put that in your calculator, I believe we get 58.25. So what are the numbers that are less than 58.25? 25 and 45. I don't see any other ones. Okay, so then for the upper boundary, we do 89.5 plus 1.5 times 12.5. Let's see what we get. 89.5 plus 1.5 times 12.5, and I get 108.25. So that means there are no upper outliers. There's only lower outliers. Okay, so I have a number line drawn here. I counted by 20. I started at 20, counted by 10s up to 100. So let's take blue and let's go above and do our Q1, our median, and our Q3. So Q1 is 77, so somewhere around here. Median is 82, so about, oops, right there. And then 89.5, so about right there. And that still gets connected and makes a box. So let's go out to the highest number that's not an outlier, which is 98 at the top. The highest that's not the lowest that's not an outlier is 60. And then we're going to put a star above 45 and 25.